Probability. So we got a bunch of objectives here, blah, 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 blah. Lesson 1, experimental and theoretical probability and odds. Let's jump right into example 1. By the way, some grammar. So I wrote down here, visualize rolling a die. For what it's worth, Kyla, 1 die, 2 dice, in case you're wondering. And I am a grammar nerd, so almost always I will call it a die, not a dice, because I'm going to try and be grammatically correct. You want to take your backpack off and stay a while? I don't know. It's up to you. Yeah, just saying. Okay. So I'm starting out with something you all know, especially those 4 of you that were late today. Visualize rolling a die. What's the theoretical probability of getting a 5? You all know this? Colin. Okay, we're going to teach you some notation. Here's what I don't ever want to write anymore. What is the theoretical probability of rolling? Way too much writing. So we have a symbol that we use, or an abbreviation that we use for probability. What letter do you think we use for probability? Okay, so we write it this way. First of all, let's get this going. We use for probability a capital P, and then in brackets we put the condition or the event that we're talking about. If I wrote that, I would read that in this context as, oh, what's the probability of rolling a 5? Nice and short, much shorter than writing that out in English. So P for probability, and the event goes in brackets. And Colin, what did you tell me? What did you tell me? What? Yeah, 1 and 6. Okay. Now that's the theoretical probability. Does that mean if I roll it 6 times, I'm guaranteed to get exactly 1 5? Or better yet, B, suppose we rolled a die 300 times and a 5 came up 62 times. Based on this results, what's the experimental probability of rolling a 5? Well, if you did the experiment, you would say the experimental probability is 62 out of 300 if you perform the experiment. Which is, if I change that now, can all of you get your calculators out? Yep. Showing you some handy-dandy features. Things you did not perhaps know that your calculator did. First of all, can all of you go Shift Setup, which is Shift Menu? And you want to double check that where it says fraction result, it says D over C. Does it? Yeah? And what that's saying is, if I get a fraction, do you want me to display it as an improper fraction or not? I like things as improper fractions. It's more easy to understand. So if you go back to menu, back to your, exit, sorry, to get out of this, exit, you have a fraction button. Any of you know where your fraction button is? It's this A, B over C button right above the 7. If you type 62, fraction button, 300, and hit enter or execute, it'll reduce stuff to lowest terms for you. That's 31 over 150, which is kind of convenient. So if you need to reduce a fraction to lowest terms. Now, we are in our work never going to reduce fractions to lowest terms, except maybe in our final answer at the very, very end. But that's handy to use along the way. How do I change a fraction to a decimal? You can either go 31 divided by 150, or you can use the button right next to it, which says fraction to decimal. Okay? So this is approximately 0.206 repeating. That 6 didn't show up very good. Where this first one is approximately, if I go 1 divided by 6, 0.166 repeating. Jordan, is the experimental probability and the theoretical probability the same number? Did I get the same answer for A and B? Why? Well, All probability means is it's telling you the likelihood of an event occurring. It's not guaranteeing that that event will continue to occur in exactly that likelihood. But, part C, suppose we rolled the die 3,000 times, or 300,000 times, or 3 million times. What do you think would happen to my experimental probability, the answer I got for B, when I compared it to the answer I got for A? They become closer and closer. Your experimental probability will get closer and closer and closer and closer to your theoretical. In other words, if I roll the die exactly 6 times, in theory, I should get only 1 5. Will I? Probably not. If I roll the die 6 million times, in theory, I should get 1 million 5s. I bet you I'd get something in the 999,000 range, or in the 1,100,000. I'd be really close. If I rolled the die 6 trillion times, in theory, I should get 1 trillion 5s. I'd get closer. Probably not exactly 1 trillion again, but closer. The more times I do an experiment, the closer the experimental approaches the theoretical. From now on, we're always going to talk about the theoretical, but I always have to point this out because sometimes even if the odds are in your favor, you still lose. It happens. Okay? So, the experimental probability closer and closer to the theoretical probability. Oh, you know what? I even wrote it here as a little probability. Let's try that again. Probability. I even wrote it here as a fill in the blank. The larger your number of experimental trials, the closer your experimental, your actual, hey, trying the event probability will match your theoretical probability. Standard deck of cards. How many cards are in a deck? What are the odds of me right now? What is the probability of me picking an ace of spades? 1 out of 52, exactly. Okay? Could I do it on the first draw, though? Yeah, my experimental probability would suggest then that it was guaranteed because I tried it once and I'd gotten an ace and, oh, it's 100%. Well, no. If I keep repeating that experiment over and over and keep tabulating my results, eventually, over the long haul, my experimental probability would eventually match my theoretical probability. There's a shorthand version of that in Las Vegas. They say it this way: the house always wins. Because the house, the casino, will set up games where the odds of you winning maybe is 49% or 48%, so that you'll win often enough to tempt you to keep playing, but the longer you keep playing, the more and more likely it is that they come out ahead. The longer you gamble, the more guaranteed it is you go broke. Oh, by the way, most of the Las Vegas games are not 48 or 49%. Most of them are like 10 or 11% chance of you winning. But they have lots of shiny lights and clinking things to make you think that you're winning. They've got it down to a sad science. Some terminology. So probability theory deals with the mathematics of prediction. The following terminology will be used. First thing, a trial is any operation whose outcome cannot be predicted with certainty. For example, tossing a coin. I can tell you what 2 possibilities there are, but I don't know the outcome of that trial ahead of time. Or picking a card. An experiment consists of 1 or more trials. How many lates did we have today?
4.
How many experiments did we have today in rolling a dice? 4. Did we know ahead of time what they would roll? I could hope. I could only hope. But I'm willing to leave it up to the fates. An outcome is the result of carrying out the experiment. Example, we use curly brackets these funky ones, which I can't draw very well, to symbolize an outcome, to list the outcome. If you're flipping a coin, an outcome would be heads. If you're rolling a dice 3 times, you could get a 3, another 3, and a 5. That would be one possible outcome of performing that experiment 3 times. This word we're going to use a lot, a sample space, and often we use a capital S to abbreviate sample space of an experiment, is the set of all possible outcomes. When you flip a coin, what are the 2 possible outcomes? What's the sample space? Heads or tails? H, probably for heads. You're gonna, oh, by the way, we often abbreviate the first letter of the, so for heads we'll use an H, for tails we'll use a T, for a jack we'll use a J, for a king we'll use a K, for numbers we'll actually use the numbers, and those will be most of them. Hey, what's the sample space for rolling a die? Hello, what's the sample space for rolling a die? 1, 2, 3, 4, 5, 6, right there. Hey, what's the sample space for rolling 2 die? Well, 2 dice. I could get a 1 and a 1, I could get a 1 and a 2, I could get a 1 and a 3, I could get all the way up to a 6 and a 6. So the sample space, oh, what's the sample space of a deck of cards? Every card. We're rarely going to list out sample spaces because that's a lot of work, but we have to be able to be able to identify the sample space before we actually can calculate the probability. We have to be able to. Oh. An event is a subset of the sample space. For example, when you're rolling a die, the sample space is 1, 2, 3, 4, 5, 6. An event could be, you get an odd number. Or you get a 1 or a 2. Flipping a coin, the event could be, you get a heads. Picking a card, the event could be, you get a black card, or you get a jack, or you get an ace of spades. And now we come to the actual definition of probability mathematically. If an experiment has a set of equally likely outcomes, then the probability of a particular event A is given by, and here's our fancy schmancy formula, probability of A is the number of favorable outcomes to A divided by the total number of possible outcomes. Say what? Far less complicated than it sounds. Colin, what are the odds of rolling a 5 when I roll a die? How come? How many ways are there to roll a 5 on a die? 1. How many outcomes are there grand total? That's exactly what this definition is. Oh, and they're all equally likely to turn up. They're all equally likely to turn up. By the way, Jordan, what's this symbol stand for? Number. What's this symbol stand for? Number. Think how many. This is why we always do counting, because if you can't count them, you can't. We always do counting methods before we do probability. If you can't count it, you can't solve it. So, example. What's the probability of rolling a die and getting a 1 or a 2? How would I write that mathematically? I would write P bracket 1, comma 2. Or you could say 1 or 2. What is the probability of getting a 1 or a 2 when you roll a die? 2 out of 6. And Jordan reduced, you know what? Let's say we're never going to reduce it unless the answer key says I need to, or if you're doing a multiple choice question and you need to. I actually find that far clearer, even though I know it's 1 out of 3, and I showed you how you can reduce for complicated fractions on your calculator. To me, that tells me, oh, how many favorable outcomes are there? 2. How many outcomes are there grand total? 6. And the 1 out of 3 doesn't quite tell me that. If an event X is impossible, we say the probability of X occurring is, mathematically, what number would I use if I wanted to show something was impossible? Okay, there you go. For example, if you're rolling a standard die, what's the probability of rolling a 7? 0. 0. Okay. If I'm picking a card, what's the probability of getting a 15? 0. There's no 15 in a deck. That may sound obvious, but it's going to actually be very helpful. If an event Y is certain, we say that the probability of Y is, what would be a good number to use to guarantee that something happens? 1. Or as a percentage, 100, because a decimal percent, you multiply by 100. So, from a well-shuffled deck of cards, a regular deck, what's the probability of me getting a red card or a black card? Sean? Guaranteed. There's no joker in here. It's either red or it's black. That's guaranteed. So the answer is going to be 1. And here's what that means then. For the rest of your probabilities, for any other event, the probability of it occurring is going to be between 0 and 1. Now, that's the mathematical way to write that. Let's write that out in English, because you guys are looking at that notation going, say what? All probability of A's will be between 0 and 1, comma, inclusive. What does that comma inclusive mean? Anything in between 0 and 1, that's what the first thing says. All probabilities of A will be between 0 and 1. Inclusive or including 0 and 1 are allowed. 0 means it can't happen. 1 means it must happen. Everything else will be between. That means if you get an answer as a decimal bigger than 1, you've screwed up. There's a built-in error check here. It's kind of nice. Turn the page. Complementary events. Suppose you pick a card from a well-shuffled deck. Now, anytime I'm talking about a deck of cards for the rest of this unit, let's assume it's fair and it's shuffled and there's no jokers and we're not missing any cards. It's the magic idealized gambling deck of cards. I'll usually write well-shuffled, but if I don't, assume it is. So, suppose you pick a card from a well-shuffled deck. The event picks a diamond has how many outcomes? How many ways are there to pick a diamond? How many diamonds are there in the deck? 13. Okay, by the way, I'll be asking you some card questions on your test on Wednesday, so you better be familiar with a deck of cards. So the fact that a whole bunch of you need to know what a deck of cards looks like. 13 outcomes. So it has a probability of, how many favorable outcomes did you just say there were, Jordan? Over how many outcomes are there in a deck of cards? 52. Now, I know in lowest terms that's 1 out of 4, and if I needed to do some math with it, I might change it to 1 out of 4, but that to me tells me more, because it tells me, you got 13 cards, 52 to pick from. I kind of like the unreduced fraction here. It's 1 out of 4 because there's 4 suits in a deck, and I can figure that out. Yes? The event does not pick a diamond has how many outcomes? How many outcomes are there for not getting a diamond? Did you count 39 different cards in your head, Roy? What did you do? Okay, we're using a trick called the complement. We're saying, you know what? The opposite is minus how many from the total. So 39 has a probability of 39 out of 52, or 3/4, I realize, but 39 out of 52. So a better, shorter way to write this, because you see I took a whole paragraph to write that. Here's how we're going to write that from now on. What would be a good abbreviation to use for hearts? H, I would write it this way. The probability of H is 13 out of 52. Or, sorry, yeah, hearts. I don't know why I went with hearts instead of diamonds. Oh, well. It's going to be the same question. I forgot to change it. And we have a great abbreviation and probability for the word not, for the word opposite. It's this. You put a bar above it. If you draw a horizontal line, from now on we're going to read that as not hearts, or not diamonds, or not a 5. And that was 39 out of 52. So Colin, I keep picking on you because you were pretty sharp. What was the probability of rolling a 5 when we rolled a die? Don't write this down. I would read that as the probability of not getting a 5. Hey, what are the odds? What's the probability of not getting a 5? Sorry? Think about it. I think you're right. Say it louder. 5 out of 6. Did you count up the other 5 ones, or did you do some clever subtraction in your head? Okay. We say that the event not hearts, we call it, it's the complement of the event hearts. It's the opposite. These are called complementary events. This means that the probability of A plus the probability of not A has to equal 1. Why? First of all, what did 1 as an answer mean? Guaranteed. Okay? So if I say the probability of A plus the probability of not A, in English, here's what I'm saying, Brooke. Something either happens or it doesn't. What's the probability that something either happens or it doesn't? Guaranteed! 100%. Something either does or doesn't happen. Guaranteed. Now, why is that so handy? Where I wrote also, I guess that means the probability of something not happening is 1 take away the probability of something happening, which is what Colin did. When I said to Colin, and what Roy did, when I said to, and what Tiffany, when I said, for example, hey, what's the odds of not getting a diamond? I hope you didn't count 39 cards. I hope instead you went, oh, it's going to be, well, the odds of getting a diamond, 13, there's 13, 52 take away 13, oh, 39 out of 52. That trick there is going to be really handy. Often we're going to find, Sean, for a probability question, it's easier to find the probability of something not happening and subtract from 1. Very often we'll find it way easier to do that. Okay? So you need to know what the complement is. You might even want to put a little star. Oh, my pen just stopped working. That's not good. Bear with me as I try and get this back. That's irritating. So as I was saying, you may want to put a little star next to here or something. So, a bit of probability. Now let's talk about odds. Odds in favor, odds against. Bailey holds all the hearts from a standard deck of 52 playing cards. He asks Morgan to choose a single card without looking. Okay. Foster is going to pick a card for us. Okay, put it down. We would like to find the odds of Morgan, of Foster, picking a face card. First of all, what do I mean by a face card? What's a face card? More specific. What are they? Okay, Jack, Queen, King. How many Jack, Queen, Kings are there in the deck? How many? 12. Okay. So how many face cards? 12. How many others? 40. What are the odds against Morgan choosing a face card? So the odds against, we would say this: 40 to 12. There's 40 ways for you to fail, only 12 ways for you to succeed. But odds we are going to reduce to lowest terms. Odds we are going to reduce to lowest terms. And if you're looking for a quick way, you can divide by 4. It's 10 to 3. And I'd prefer you to be able to reduce a fraction because it's math 8. But for what it's worth, if you're in a rush, 40, math 12, 10 to 3. Okay? Now, Mr. Dueck, wait a minute. I thought you said answers couldn't be bigger than 1. 10 over 3 is bigger than 1. This is not a probability. These are odds. This is saying how many ways to fail, how many ways to succeed. That's if we wanted the odds against. And this question said the odds, we should underline the word against. By the way, did you get a face card? Yeah. Hey, great. He beat the odds. What would the odds look like if you had an even chance of winning? We say 50-50, but what would 50-50 be in lowest terms? 1 to 1. 1 to 1. 1 to 1. Yeah, 1 to 1. Odds. I'm not talking probability. I'm saying odds. Means you have the same number of ways to win as to lose. 1 to 1. Okay? What are the odds that Morgan chooses a spade? How many spades are there in the deck? 13. How many non-spades are there in the deck? 39. What's that in lowest terms? Now, I got to be careful. We don't write this as a fraction. I am not saying the probability is 1/3. We don't write odds like that. We use a ratio with colons. We say the odds of getting a spade are 1, 2, 3. Not 1 out of 3. 1 versus 3. In other words, in 4 choices, on average, 1 will be a spade. Where'd the 4 come from? There's 4 total outcomes in the odds. See it? There's a difference between odds and probability. How much further are we going to go, Mr. Dueck? Got those. Let's go a little bit further, and then we'll press pause. So, here's our standard deck of cards. Suppose we pick one card from a well-shuffled deck. Does yours have odds in it as well? Does yours have a... Can I see your notes, please, for a second, Foster? Because I think I changed it and forgot to change it on my original. No, I did not. Well, that was silly of me. Okay. Example 2. Suppose one card is drawn from a deck of 52 cards. What's the probability that it's a face card? You know what? Let's call that P of F. One way to do this would be to count. I'm going to circle all the face cards. All the face cards are right there. How many face cards are there? Out of? How many cards are there? 52. What if I asked you for the odds? Now you would not say 12 to 52. You would say 12 compared to, whoop, not 39, Mr. Dueck, to 40. That's the odds. Or the 12 to 40 in lowest terms, 3 to 10. You got 3 to 10 odds of winning this game. You've got a 12 out of 52 chance of winning this game. A red ace. I'll use red for a red ace. How many red aces are there in the deck? See them? Right? What's the probability of a red ace? Sorry? That's the probability. What are the odds for a red ace? 2 to 50. Not 1 out of 26. 1 to 25. You see the slight difference when you're doing odds versus when you're doing probability. Okay? Las Vegas tends to give the odds, like on sports events. Okay? They use odds. They don't give them as fractions, as probability. So, again, here's our probability definition. If an experiment has n equally likely outcomes, of which r outcomes are favorable, then the probability of event A is r over n. How many successes over how many total outcomes? And this brings us to our first one. You know what? If you can count it, you can find the probability. Rachel, you going to make it? You're not looking good. You're still on Black Friday. Okay.